Hi everyone, in this video I want to say more about how to inspect the convergent and discriminant validity of a multi-item scale. Now in our case we use the file Argentina-Brazil. That is a world value study in another year than the one that you will analyze during your assignment. Okay, so when we want to analyze convergent and discriminant validity, we first inspect a multi-item scale. Now in our case, let's first look at the column names of my data file. I know, when I read the code manual, I know that these items from 7 until 12 actually relate to a scale that relates to environment. The first 3 items about how people feel about the environment in the community, so in the near surroundings, and the other 3 items about the world. So if we want to select those items, we can simply use numbers to select these columns. Now indeed, these are all the answers that people gave to these 6 items. So as you can see, the labels are on top. Now, to inspect the convergent and discriminant validity, we have to do that by first creating a correlation matrix. So that's core, and if we just run it, we have to also specify what we do with the NAs, because we saw here that there are NAs. So if we don't specify what we do with the NAs, we get a correlation matrix, but only with NA values. So let's use pairwise deletion. Now pairwise allows you to also take into account, so for instance this person here did not fill out the 3rd item but did fill out the other items. So pairwise deletion takes into account these answers when the correlation between these 3 items are calculated, but not when it is correlated, when the correlation treats the one item that it did not answer. So pairwise, so listwise deletion means that you just delete the whole observation by this person if it only did not respond to one question. So pairwise deletion takes out more information that is available. Now here's the correlation matrix. If we look at it, we see that indeed, here the first 3 numbers actually relate to how these 3 items about the community relate to one another. We also see that on the diagonal, which are the variances, is 1, because we have a correlation matrix, so it also relates to one another at 1. How do we interpret this coefficient or this number? It means that we have to interpret this in terms of standard deviation, because it's a correlation, so it's standardized. Which means if one goes up in B019 by 1 point, or 1 standard deviation, it would go up in B018 by 0.74. Now, so it means that these 2 are pretty highly related, because if somebody compared to another person that scores 1 standard deviation higher on one item, that person will likely also score a 0.74 standard deviation higher on the other item. Now, this means that as these numbers are really high, the correlation coefficients, you can say that this has a high convergent validity, this scale. So actually this is the part, and then here, which is can be used to test the convergent validity among the first 3 items. Now you see that this number is the same as here, so it's like either you use one part or the other part, it doesn't matter, right? The upper part or the lower part say the same thing. Now, if we go inspect how these 3 the answers on these 3 items actually relate to the other 3 that actually concern the world, there we see that there's a much lower number. So this means that these items, the answers on these items, actually discriminate really well with these items. So we see indeed that it's a very low number. Now the same can be inspected here, which is the convergent validity of the last 3 items. So there again, I mean, it's higher than these correlations, but still it's not that high, right? So we would say that these 3 items have a lower convergent validity than these 3 items. Okay, another thing that I would like to show you is that if you want to save this into an object, then you can actually use lower 3 to get to all the numbers that are below the diagonal. Yeah. So you see, here I have all the lower numbers. You can also get to the diagonal by using diagonal. Now I think the same thing can be done with a covariance matrix by just changing this R by cov. And there you see that on the diagonal are not the ones, because now it's a covariance, not a correlation anymore. And there you see that indeed there are the variances, the covariances, or the variances, sorry. Yeah.